Your agent gave a wrong answer, or it cost $5, or it hung for 30 seconds. You open the logs, you read the final output, and it tells you absolutely nothing about why. Because an agent run is not one call, it is a tree of nested calls, sometimes dozens deep. The agent calls the model, which picks a tool, which returns a result, which triggers another model call, and on it goes. Here's the core idea. To debug an agent, you have to see the whole run, not the final line of it. And that is what a trace gives you. But first, separate two words people use interchangeably: monitoring and tracing. Monitoring aggregates health across many runs and over time: request rate, error rate, P95 latency, token cost, and tool failure counts. It detects a fleet-level symptom and fires the alert. It tells you that something is wrong. Tracing follows one single run through its nested operations. It tells you where exactly which model, retrieval, or tool span waited, retried, or failed. In practice, they are a pair. A latency monitor pages you, one representative trace reveals 3 retries in a single tool call, and the dashboard then confirms the fix across all your traffic. So what does a trace actually capture? It records the full execution as the nested spans, one span per operation. Each span carries its timing, its inputs and outputs, its token counts, and its cost. And suddenly the bugs that were invisible in the final output jump straight out at you. A retry loop where one tool silently retried 3 times and ate half your latency. The wrong tool called, or a tool called with bad arguments. A cost spike, and you can see exactly which span spent the tokens and on what. Or an agent looping instead of converging, slamming into its step budget. Now what do you instrument? Look at the code shape. For the whole run and every span, you log the inputs and outputs, the model and prompt version, the token counts, the latency, the cost, and the tool name with its arguments. Notice the fetch span in the code. It wraps the call, retries on a timeout, and records each attempt as an event. So the loop is right there in the tree. And you tie every span to one trace ID, so a single run becomes one searchable object. You do not build this yourself. LangSmith, Langfuse, and Arize give you trace trees, token and cost dashboards, run replay, and dataset capture. And they increasingly speak OpenTelemetry, so your agent traces flow into the same observability stack as the rest of your services. There is a bonus too. Those captured production traces become the seed for your eval sets, so real runs turn into test cases. Wire up tracing before you ship, not after the first incident, because flying an agent blind is how silent regressions reach your users.